What if the same ocean that powers our cities could also feed them? Imagine vast open waters, not just as empty spaces, but as thriving hubs of clean energy and sustainable food, working in perfect harmony. This isn't science fiction, it's the next frontier in our fight against climate change. Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're diving deep into a revolutionary concept, combining offshore wind farming with agriculture. As our planet faces the dual crises of a changing climate and a growing population, innovators are looking to the oceans for a solution that addresses both energy and food production at the same time. Societies are being forced to completely rethink how we generate power and grow our food. And the vast, underutilized expanse of our oceans holds immense potential. Combining offshore wind with agriculture is an incredibly attractive model because it tackles two of our greatest global challenges simultaneously. It provides a path to dramatically reduce our carbon emissions while also bolstering global food security. This fusion of green energy and blue agriculture could redefine sustainability. So let's explore how this innovative synergy is poised to become a reality. First, let's break down what offshore wind farms are and how they work. At their core, these farms are collections of massive turbines installed in bodies of water, typically oceans. These turbines harness the power of the wind to generate electricity. As strong, consistent ocean winds spin the enormous rotor blades, they turn a generator, converting kinetic energy into electrical energy. This power is then transported to shore through heavy-duty, subsea transmission cables, where it's fed into the national grid to power homes and industries. The potential of offshore wind is staggering. Countries like the United Kingdom, Denmark, and others across Europe are leading the charge, with massive projects expanding rapidly in areas like the North Sea and the Atlantic coast. The United States is also ramping up its efforts, recognizing that offshore sites offer a significant advantage over their land-based counterparts. The winds are generally stronger and far more consistent. However, capitalizing on this potential requires careful planning. These large-scale projects demand significant ocean space and must be strategically allocated to avoid interfering with critical shipping lanes and sensitive marine ecosystems. While offshore wind is a powerful tool for reducing our reliance on fossil fuels, its environmental footprint must be managed. The design, construction, and operation of these farms have to be meticulously planned to minimize any negative impacts on marine life, from seabirds to deep-sea habitats. The real magic happens when we connect this clean, offshore energy with agricultural systems. This synergy creates a powerful self-reinforcing loop of sustainability. One of the most promising applications is powering vertical farms on land. These high-tech indoor farms can grow massive amounts of produce in a small footprint, but they are incredibly energy-intensive due to their reliance on artificial LED lighting and precise climate control systems. By connecting them to a dedicated offshore wind source, we can power these farms with 100% renewable energy, making our food supply both local and carbon neutral. Beyond vertical farming, offshore wind can address another critical agricultural challenge: water scarcity. The clean electricity generated at sea can power desalination plants located along the coast. These plants turn salt water into fresh water, providing a reliable source for irrigation in drought-prone agricultural regions. For coastal communities struggling with dwindling freshwater supplies, this combination could be a game-changer, ensuring that farms can continue to operate even as climate change intensifies. Furthermore, the integration doesn't stop at the shoreline. The very infrastructure of the wind farms can create multi-use ocean spaces. The turbine foundations can double as support structures for aquaculture, coexisting with seaweed farms, shellfish cultivation like mussels and oysters, and even contain fish cages. This creates a symbiotic relationship where one space serves multiple purposes, maximizing resource efficiency and delivering both food and energy security from a single location. Fueling this revolutionary integration is a wave of technological innovation. Engineers are developing hybrid platforms that combine floating wind turbines with large arrays of solar panels. These floating solar and wind farms can diversify renewable generation, capturing energy from both the sun and the wind to ensure a more consistent power supply, day and night. To manage these complex dual-purpose systems, advanced AI monitoring platforms are being deployed. These smart systems use sensors and machine learning algorithms to track everything from energy production and turbine health to water quality and fish growth rates in co-located aquaculture farms. This allows operators to optimize both systems simultaneously, ensuring maximum efficiency and output. Connecting this offshore power to where it's needed on land requires sophisticated smart grids. These intelligent networks can dynamically balance energy, supply and demand, seamlessly directing power from offshore wind farms to coastal farms, desalination plants, and urban centers as needed. This ensures that not a single kilowatt of clean energy is wasted. Together, these technologies are what make the large-scale integration of offshore energy and agriculture not just a theoretical possibility, but an efficient, scalable, and economically viable reality. This isn't just a futuristic dream. Pilot projects and case studies are already demonstrating the incredible potential of this synergy around the world. In Scandinavia, countries like Norway and Denmark, which have deep expertise in both aquaculture and offshore engineering, are at the forefront. They are actively experimenting with integrated platforms that combine offshore wind energy systems with advanced fish farming operations. These projects are testing the technical feasibility and economic viability of creating self-sustaining offshore hubs for both food and power. In the United Kingdom, major projects in the North Sea are pioneering models of coexistence. These initiatives are focused on testing how large-scale wind farms can share marine space with aquaculture operations, developing best practices for managing these shared environments and demonstrating that energy generation and food production can happen side by side without conflict. Meanwhile, in the United States, the focus is increasingly on the energy-water-food nexus. New offshore wind projects are being linked with desalination pilot programs, particularly in coastal states facing water stress. These projects are exploring how to use abundant, clean energy to create a new, drought-proof source of water for both coastal communities and agriculture. Each of these case studies serves as a crucial proof of concept, providing valuable data and lessons that will encourage the scaling of these integrated models on a global level. The environmental and economic benefits of this integrated approach are immense. By powering agriculture with offshore wind, we can dramatically reduce the food industry's reliance on fossil fuels, significantly lowering the carbon footprint of everything from irrigation to processing and transport. This synergy creates what experts are calling blue-green economies, vibrant, innovative economies that strategically combine marine blue and terrestrial green resources to maximize productivity while minimizing environmental impact. This fusion doesn't just benefit the planet. It creates a wave of economic opportunity. The development of these integrated systems will spawn entirely new industries and create thousands of high-quality jobs. Opportunities will emerge in renewable energy engineering, advanced aquaculture, marine biology, AI, and robotics, and sophisticated coastal management. Countries that take the lead in developing and mastering offshore agriculture integration will not only secure their own food and energy supplies, but will also position themselves as global technology exporters, selling their expertise and innovative systems to the rest of the world. This creates a powerful economic engine fueled by sustainability. However, the path to this integrated future is not without its challenges. The upfront infrastructure costs are substantial. Building robust offshore platforms, laying miles of undersea cables, and integrating complex aquaculture systems requires massive investment. There are also significant environmental considerations. The construction and operation of offshore infrastructure can disrupt marine ecosystems through noise, habitat alteration, and changes to local ocean currents. Careful, science-based planning and advanced engineering solutions are essential to mitigate these impacts. The regulatory landscape is another major hurdle. Governments must navigate a complex web of competing interests, including commercial fishing, shipping, conservation, energy production, and food security. Developing clear, cohesive policies that allow for multi-use ocean spaces while protecting traditional livelihoods is a delicate balancing act. For this model to gain widespread social acceptance, it's essential to work collaboratively with existing marine stakeholders, especially traditional fishing communities, to ensure that the development of offshore farming does not come at the expense of their rights and heritage. Looking ahead, the future of offshore wind farms is likely to be far more dynamic than just energy generation. These sites are poised to evolve into multi-purpose ocean hubs. Imagine a single offshore platform that not only generates clean electricity, but also houses a large-scale aquaculture operation and a desalination plant, creating a closed-loop system of energy, food, and water. Automation will be key to managing these complex operations. AI and robotics will be used to automate everything from turbine maintenance and system monitoring to fish feeding and seaweed harvesting, making these offshore operations safer, more efficient, and more productive. For coastal economies in countries like the United States, Canada, the United Kingdom, and Australia, this integrated model could be transformative. By embracing offshore wind and agriculture, these nations could drastically reduce their dependence on imported food and fossil fuels, strengthening their economic resilience and national security. The future of sustainability isn't about solving problems in isolated silos. It's about creating deeply integrated ecosystems where industries work together to create a circular, regenerative economy. In conclusion, the combination of offshore wind and agriculture represents a paradigm shift, a powerful system that delivers clean energy and sustainable food in a single, elegant solution. It is a bold vision for a future where we harness the power of our oceans to build a more resilient and sustainable world. To make this vision a scalable reality, we need a concerted effort from all sectors of society. It will require bold innovation from scientists and engineers, strategic investment from the private sector, and supportive policies from governments. But it also requires us to change the way we think about our resources. We invite you to imagine the role you could play in this future, whether as an investor supporting new technologies, a policymaker championing integrated marine planning, a farmer adopting new sustainable methods, or a consumer demanding cleaner food and energy. The potential is limitless, but it begins with a shared vision and a collective will to act. Could offshore farming be the next green revolution? Share your thoughts and subscribe for more future-focused insights.